Assalamu alaikum students, this is the fourth video of exercise 3.3 chapter number 3. This contains question number 14 to question number 17. Question number 14, integral dx over under root 7 minus 6x minus x square. First step, we will take negative common from this term, which will be as dx over under root negative bracket x square plus 6x minus 7. Now we will try to complete square. Here we will get dx over under root minus bracket x square plus 6x, as this is the term a square, this is 2ab, this will be b square. So adding plus 9 and subtracting 9 at the same time, we get integral dx over under root negative, this will be completed as x plus 3 whole square, and minus 9 and minus 7 will add up to negative 16. Now multiplying the negative sign, we get dx over under root 16 minus x plus 3 whole square. 16 can be written as 4 square, so this term will become dx over under root 4 square minus bracket x plus 3 whole square. Now using the formula, which is integral 1 over under root a square minus x square dx is equal to sine inverse x over a plus c, this value becomes sine inverse x plus 3 over 4 plus c. Moving on to question number 15, which is cos x over sin x into ln sin x dx. Putting ln sin x is equal to t, taking differential on both sides, which get 1 over sin x cos x dx is equal to dt. Now finding the value of dx, by this we get dx is equal to sin x over cos x into dt. Putting the value of t and dx in this equation, we get integral cos x over sin x into t into sin x over cos x dt. Now sin x will be cancelled by sin x, cos x by cos x, we will get integral dt over t, which is equal to ln t plus c. Now putting the value of t, which is ln sin x, we get the answer ln sin x plus c. Moving on to question number 6, which is integral cos x into ln sin x over sin x into dx. Putting ln sin x is equal to t, taking differential on both sides, we get 1 over sin x cos x dx dt. Finding the value dx, we get dx is equal to dt sin x over cos x. Putting the value of dx and ln sin x in the question, we get integral cos x d over sin x into sin x over cos x dt. Sin x will be cancelled by sin x and cos x will be cancelled by cos x. We will get integral t dt. Taking integral, we get t square over 2 plus c. Putting the value of t, we get ln sin x whole square over 2 plus c. Moving on to question number 17, which is integral x dx over 4 plus 2x plus x square. Now for this, multiplying and dividing by 2 and adding and subtracting 2. Now breaking the LCM, we get 1 over 2 integral 2x plus 2 is the derivative of this function. So we will separate it like this, 2x plus 2 over 4 plus 2x plus x square, and the remaining 2 is separated again, which will be equal to negative 2 over 4 plus 2x plus x square dx. Now multiplying 1 over 2 on both sides, we get 1 over 2 integral 2x plus 2 over 4 plus 2x plus x square dx. This 2 will be taken as common, which will be equal to minus 2 over 2 integral 1 over. Now we will try to make a square here. For this I have added 1 and subtracted 1. Now this value will constitute a square, which will be written as 1 over 2 ln. Now taking in differential on this, we get 1 over 2 ln x square plus 2x plus 4. For this term, this will be a complete square, so it can be written as dx over x plus 1 whole square plus minus 1 and plus 4 equal to plus 3, which can also be written as under root 3 whole square. Now using the formula, dx over 1 plus x square is equal to tan inverse x, we get 1 over 2 ln x square plus 2x plus 4 minus integral dx over x plus 1 whole square plus under root 3 whole square. We will get 1 over 2 ln x square plus 2x plus 4 minus 1 over under root 3 tan inverse x plus 1 over under root 3 plus c. That's all for today.